Now we move on to the next event, which is independent event. Now, independent event can be said as two events which not affected by each other. For example, if you have event A and you have event B, so therefore event A does not affect the outcome of event B. For example, let's say I have a dice and then I have a coin. I have a dice and a coin. Okay, now I roll a dice and then I flip a coin. The outcome of the dice does not affect the result of the coins. If you get the value on the surface of dice is 6, the coins will not give you the number 6. However, it gives you either tails or head. So this is example of independent event. Example of independent event is like this. Let's say if you have a bag full of balls, and in that balls you have a blue color balls, red color balls, and a yellow color balls. When you reach into the bags and choose a balls without looking at it, when you take it one times and you record the color of the balls and then you replace the balls back, or you put the balls back in the bag. So this condition, this situation is known as independent event. Choosing a balls on the first trial has no effect on the probability of choosing the second balls on the second trial, because again you have replaced back the balls that you take at the first time. So independent event involve the words and here, A and D. So the symbol will be like this. To find the probability of two independent events that occur in sequence, we need to find the probability for each event occurring separately and then multiply the probabilities. This multiplication rule is defined symbolically as in the next slide. So note that multiplication is represented by N, A and D. We look first on this first multiplication or multiplication rule 1. Here the multiplication rule 1 states that when two events A and B are independent, the probability of both occurring is written as probability of BA and B is equals to probability of A alone times with probability of B. Okay, now we look at the experiment here. A drawer contains 5 pairs of socks with blue, brown, green, purple and black color. A pair of socks was chosen without looking and the color is noted, and then it replaces it back. Then you choose another pair of socks. So now, what is the probability of getting green socks? So you have to identify that probability of getting green, I denote as G, is 1/5. You only have 5 pairs and each will have blue, brown, green, purple and black. So probability of getting green is 1/5. So the event here is getting green socks on both event. So let me add up here for both event or times. Okay. So probability of getting green for the first time and another green for the second time will be, remember the multiplication rule for the independent event of A and B will be this. So now here A is your green for the first time, B will be your green sock choose at the second time. The probability of getting both sock green will be 1/5 times with 1/5. So probability of getting results in both event or in both times will be 1 over 25. So this is example on multiplication rule 1. We move on to the next part, which is dependent event. The condition of dependent event is that the outcome of the first event affect the outcome of choosing the second event. So here the probability value will change. The probability is changed. Example of dependent event is here. Let's say I have a bag of marbles here. First event, I took out the pink marble. The color is noted and I put it aside. I do not put it back, or I do not replace the marble inside the bag. So the total marble inside the bag after the first marble has been taken out will be reduced. Total here will be 12. Now if I took one marbles out, the pink marbles out, and do not replace it back, the end here will reduce to 11. If I take out another ball, let's say I take out yellow balls and I do not replace it back, so the next number of total marble in the bag will reduce to 10. So here where you can see that the first event affect the outcome of the second event, or in other words, the total number of marble in this bag change. For example, take out one marbles and then take out another marbles. So the probability is changed in this dependent event. Okay, now we look at experiment on this dependent event. On a statistic test, 5 out of 20 students got an A. If 3 students are chosen at random without replacement, what is the probability that all 3 got an A on the test? Okay, to solve these problems, you have to identify what is main information that you need to retrieve. So here it asks you to find the probability of all the 3 students who get an A. So probability here, 3 students and A. Okay, probability of 3 students and A. So now the first student that we choose with A is 5 over 20. Then once you have choose one student and you do not put it back with names list, so the number of students with A's will be 4 and the denominator will change. It will become 19. So this is the second student. Now the third student with an A, the probability will be reduced. The number of the student with A reduced. You do not replace back the list of the student. So here we'll get 3 students with A's, and your denominator will also reduce. It will become 18. So from this information, the probability that all 3 got an A on the test will be 1 over 114. So this is how you solve for dependent event. Another way to illustrate the information of this dependent event, you can use tree diagram. Now let's say I'm using this kind of tree diagram. The first branch I denote for A's, and the second branch here is others other than A, or A prime, A and A prime. Okay, now this is first event. A is 5 over 20 and the rest will be 15 over 20. This is your first event. Now the second event of getting A, and this one will be A prime. This is also will be illustrated as A prime. Now I'm only focusing of A. Students, 3 students with A Okay, so after I have choose 5/20 here, after I have just one student from the first task and then I do not replace back, so this will be 4/19, and here will be 15/19. Okay, this is the second task. The third task is student with A and student with A prime. So once I have for the second part I have drawn out student with A's, the third part I need a student with A's. It will be 3/18, and this will be 15/18. So this is another way of you illustrate the information for dependent problem. We look into another example. Okay, another experiment. Two cards are chosen at random from a deck of 52 cards without replacement. The word here is without replacement. What is the probability of the first card is queen and the second card is 10? So in a deck of cards, the total number of queen is 4/52. There are 4 queens. You have 2 red queen and 2 black queen. For tens, you will also have 4 of card with number 10. So here I will put as P10. However, okay, here will be 4. However, the denominator will reduce because you have picked the first one queen and then you did not replace it back. So the denominator have changed. So it will be 51s here. So probability of getting queen and number 10 from a deck of cards will be 4/52 times with 4/51. So you will get 16/2652. And this number can be, you can make it smaller. So it will be 4/663. In this experiment, it involved 2 compounds dependent event. The probability of choosing a number 10 on the second pick, given that a queen was chosen on the first pick, is called conditional probability. The conditional probability of an event B in relationship to an event A is the probability that event B occurs given that event A has already occurred. Therefore, the notation for conditional probability is P B given A. This is the notation for conditional probability. The pronoun is that the probability of event B given that A already occurred. This symbol is known as given. This notation does not mean that B is divided by A. However, it tells you the probability of event B given that event A has already occurred. To find the probability of these 2 dependent events, we use modified version of multiplication rule 1, which was presented in previous slide. Multiplication rule 2 says that when 2 events A and B are dependent, the probability of both occurring is given as probability of A and B occurred is equals to probability of A times with probability of B given A. Usually we illustrate the information or reveal the information of conditional probability using the tree diagram. For example, let's say this is 2 events. The first one is event A. A already occurred. Okay, another branch will be represented by A prime, complementary of event A. Now, event A is the first event to happen, followed by event B. So it will be B and B prime, complementary of event B. So if event A prime occurred, so the second one will be B or B prime. So this here will be probability of A. Okay, and second branch is probability of A prime. And for the second event, it will be probability of B given A. The second branch of the second event will be probability of B prime given A. So if we multiply this first branch here, it will be probability of A times with probability of P given A for this part. So here is the outcome of your Terray diagram for conditional probability. We look for the experiment for this conditional probability. Encik Saiful needs 2 students to help him with a science demonstration. His class consists of 18 boys and 12 girls. So he randomly chooses the first student who is seated at the back of the class and the second student who is seated at the front of the class. So what is the probability that both students selected are girls? So let's say the first branch represent the girls 1, boys 1. Okay, why is 1 here? Because this represent the first event. So how many girls that we have here? We have 12 girls out of 30 students. 18 plus with 12, your total sample or total student will be 30. Okay, so the girl will be 12, the boys will be 18. So the probability for the boys on the first event here will be 18 over 30. Now, the situation here is that both students are girls. Now, let's say the first one you have choose girls. For the second event, here I put it as G2. It will be either girl or boy. Once you have picked up the first girl, so the number of girls on the second event will reduce. So here you will have 11 over 29. So this situation here, the number of boys remain the same except for the denominator. So it will be 18 over 29. Condition or the probability that you want to find is both students are girl. First event you choose is girl, and the second event that you choose is also a girl. So it will be probability of selecting a girl at the first event times with probability of selecting girls on the second event, given that the first event selected is also a girl. So probability of girl at the first event will be 12 over 30, and the probability of selecting girls at the second event, given that the first one is girl, is 11 over 29. So the total probability of selecting both girls is 22 over 1, 4, 5. So this is your probability of getting both students.